Okay, hey folks. So I'm not there today, and I just kind of wanted to go over our lab so that we can see how to do stuff. Okay, so I think I have it working again. So I just real quick wanted to go over what we're going to be doing today. So again, we'll start with our meme again, some of our disappointments in evolution. Um, anyway, all right. Our joke for today: why should you always knock on the refrigerator door? Well, because the salad might be dressing. Nope. All right, so again, last week we looked at real world populations. We took a look at our three um, case studies, our hawksbeard, our juncos, and our rats, and we took a look at how that they are using natural selection and adaptation in their urban environments. We looked at, again, the plant seeds, how they produce the non-feathery seeds in urban areas, how the juncos are more bolder than the mountain ones, and how the rat populations developed a poison to resistance, or resistance to poison. Um, and so all this is really doing is just talking about our model, which you can find in the notebook channel. Then we looked at analyzing data, so our line of best fit or our trend line, understanding not negative and positive correlations without just assuming causation. We looked at the Juncos experiment that showed boldness differences are likely inherited. We looked at the common garden experiment. We clarified the difference between correlation and causation. We looked at the correlation coefficients and how it measures the strength and direction of the relationships. And then we took a look at the data for the juncos and their cortisone levels, emphasizing that just because we have correlation doesn't necessarily prove causation. The next one, then today we're working on habitat fragmentation. So what you'll do now is go ahead and you'll log into your teams. Okay. As you see your team, okay. As you see your teams here, you'll see here's today's PowerPoint. And then here is our assignment. So just like always, you can click on it. Okay, here we go. So again, this is the one in Teams. This is not the one you want to write on. This is not the one that I'm going to get. Okay, so just as a quick reminder, file, create a copy, download a copy. Okay, download. Now you have your own. So you're going to click on it up there. Okay, and it should be opening it in your OneDrive. So I'm going to stop share and try. Okay, so this should be the one that is in your OneDrive. Now, again, you need to make sure that, or the one in your downloads. So you have to put it in your OneDrive, save as. And again, none of this should be new to you. We've been doing it all year. Put your name in it. Tiff and Bob. I don't know. That's who we're going to do. So Tiff and Bob are working on this. Okay, and then I can share it to my teacher, share. And then we put in Tiffany Adams. Look for Animal the Muppet. And then you can send it. Okay. Doop, and that says you're invited. Now, at the same time, I can take a look at this in case anything happens to it. I'll have a copy of it. It's constantly being saved, so you don't have to fall out of college. Oh, wait, fail out of college like I did because it didn't save. But I'll have access to it, so if anything, you can see it. Now, obviously, I can't really see this right now, so we want to zoom it in. Okay, as we zoom in, we can take a look at today's directions. Okay, so we're looking at the PhET Natural Selection Lab, fragmentation and genetic diversity. A little bit of introduction because we want to take a look at how is this going to relate to world and what kind of the rest of our unit. Sorry, I caught a little bit of a cold too. So we're looking at the Florida Panthers and what happened to them. And then we're going to also take a look at challenges near Buckeye, Arizona. We're going to actually use the Buckeye, Arizona, the rest of the unit. So we kind of need to just take a look at some of the things about it. So first off, a couple bullet points instead of making you read the whole thing. Again, so if you are working with a partner, then again, you're going to download and share it with them as well. At the PhET Natural Selection Simulation. We're going to take a look at how the model fragmentation and selection pressures affect population. We're going to reflect on urban design and resilience and conservation. We're going to look at mutation performances under selection pressures. We're going to track allele frequencies and population and pedigree data, explore combination mutations with multiple pressures, analyze data with trend lines, correlation, causation, and correlation coefficients. And then there's some reflection questions. We're going to be looking at trait frequency. So I wanted to make sure you knew how to find that. And that's just going to be the number of individuals with the trait or the mutation that you, the dominant mutation that you are introducing, divided by the total population, which gives you a fraction. And then you just multiply it into 100 so that you have your percentage. Okay, we're going to take a look at our two tests. The first one where we're going to test, let me change that. This is over 5 generations. One mutation and one environmental factor at a time. We don't want to change too many variables at once because then we're not sure what's going to happen. And then after that, you'll do 3 generations. Actually, then this one is the 10 total. I will try to fix that in the final one so it's not confusing. And then you're going to do all of the mutations with all of the environmental factors as part 2. We're going to take a look at the changes in the trait frequency and apply those environmental pressures. We're going to then take a look at our patterns and analyze timing with generations. So check to see if the trait frequency changes immediately or shortly after the environmental factor is introduced. Look for consistent patterns across the trials. Consider biological reasons explaining trait advantages. We're going to be looking at strong correlation, perfect, positive, right, weak, or no correlation. So you'll be doing that. And then we're going to be looking at, does correlation alone, well, we already know that correlation alone does not prove causation. So then here is how we decide whether it's correlation or causation. Then we're also going to look at the pedigrees to just practice our looking at our alleles and inheritance frequency increase in after we to see if that supports our causation. Okay, so here again we're going to take a look at the simulation. I think that this is going to be a case where we're not going to be able to do this. Unfortunately, we're not going to be able to do it on paper. So we're going to be showing you how to do this openly with the computer. And first, we're going to want to go back to our link. I'll insert it again here just so it's easier to get to. But we need to go to our link to show what we're doing. Okay, and so go ahead and click on it. I will stop sharing and then put it to this one so that you can see where to share now. Okay, you can have one person, if you're working in a partner, one person with the PhET lab up, and then the other person can be doing the paperwork if you want. So you can have your recorder as well as then your facilitator, however you'd like to work that. We do not want it on intro. We do want to put it on the lab tab. So make sure that you have your lab tab here. Here is a situation where you can control your weather. If you want to have sunny bunnies, here you go. If you want to have winter bunnies, here you go. Excuse me, I apologize. Add mutations. So here's your fur. Another mutation is we're going to look at long ears versus short ears, and then long teeth versus shorter teeth. We're going to, environmental factors. We're going to have wolves, tough food, and limited population. Okay. Here just kind of keeps track of this is your key. You'll be doing a similar key however you want to, but you want to have a key so that you can know what it is you're going to be graphing. In your graph, you're just going to do the dominant traits with the environmental factors, so you won't have it to be quite as intense as this one. The first thing you're going to want to do is fur with wolves. Okay, but you want to make sure that you have at least one generation complete before you add your environmental factors. So I'm going to add my mate. Now I have my 2 bunny rabbits. Okay, I'm going to add my mutation. You can see my clock is ticking down. Doo, doo, doo. Okay, so now we've mated, and now we can go ahead and add our wolves. So I'm going to add our wolves as our environmental factor. Okay, at the end of generation 1, then I'm going to pause it. If I want to find out right before they mated what my numbers were, I can do it right here. Okay, so my total number of bunnies was 6. I had 5 with white fur, and then I had 1 with brown fur. So now to put that into our document, we would go back to our Word document, which is here. Okay, we'll scroll down to our tables. Okay, so generation 1, okay, our dominant trait, well, we don't know. I guess we can take a look. So how are we going to find that out? But our total population, I forgot what it was again. So let's go back here. We're going to go back to here. Okay, how do we find out which one's dominant? Well, let's go to pedigree. So to find out, right now we're just looking at populations. Click on this graph, we can see proportions, started bunnies, current bunnies, pedigree. Pedigree is going to let us know whether or not, or what our bunny's pedigree looks like. So remember, a capital letter is dominant and a lowercase letter is recessive. So if I want to look at, say, this bunny's pedigree, I can see, okay, so here were its parents, right? So they had a child, that child mated, and then this is the generation 2. So this is generation 0, generation 1, this is generation 2. I want to take a look at here because all of these are lowercase. So let's take a look at this bunny. Okay, so this is generation 0, but then the mutation was introduced in generation 1. Generation 1 then mated with another bunny, but this one has a dominant and a recessive trait because the dominant shows it's a brown bunny. Okay, so that's how you'll know. So in this case, if we're doing the sunny bunnies, then the brown fur is dominant. Looking at our populations again, 6, 5, and 1. Okay, so we can go back then to our document. Okay, our dominant trait here then is the brown fur. Okay, and it's represented with a capital F. Our total population, we have 6 bunnies. Trait frequency was 1. Was that right? 651, right? Yeah, okay, just double checking my notes here because I'm not feeling so well. All right, so what did we see here? Honestly, we haven't really seen much. We just saw that, we had some brown fur. We know that generation 0 had no mutation. Generation 1, the mutation was introduced. Okay, and then we're going to go ahead and run the simulation again. Okay, and hit play. Boop. And go to the end of generation 2. Okay, we can move our probe. Hasn't quite gotten, so this is the end of 2. Let's go here. Okay, so here is generation 3. We're back to 12 bunnies. 4 of them have white fur, but now 8 of them have brown fur. So we'll be putting that into our table and kind of keep logging it. Once you have finished, let's say you've already done your 5 generations down here. To reset, simply hit this button here. Okay, and then you have reset it again. So let's go back to our tables and take a look at what we're doing. Okay, trait frequency has not 1, but we need to take our total number of individuals that have that trait. So we would take the 1, divide it by 6, and then multiply it by 100, and that's how you'll get this trait frequency. Okay, do that for 5 full generations, and then move on to the next one. Once you get through all of the different generations with all of the environmental factors, you're going to graph it. Okay, so down here then is your graph. And because we are doing this all on line, I wanted to just kind of show you how you can do that. So go insert, you go text box, make your life a little bit easier, make your tables cleaner. I can draw a text box. Let's say I want to bring it down here. Okay, and we want this to be generation 1. Let's give it a little space in case we want to put anything in between. This is 2. Looks like we're going to be skipping 1 space in between. Okay, so as you can see, I'm going every other one. So skip that one, go here. And then you can do that through all of your generations. If you want to skip more in between, you can. What I would also do is if you can left click on this, or I think it's a 2-finger click with your guys' computers, make sure that you have the fill at no fill and no outline. And then that just means that if you need to move this up and stuff, it should not be covered because this has a no fill. Well, I'm not sure that did work. Go back. Okay, so click on it again, fill, no fill, and that means I should be able to, there, see, now you can see it. So if you have to end up moving things around, you'll be able to. Now we're going to need to set this up to percentages. Okay, so you can kind of just copy and paste this if you wanted to, and then take it and then you just rotate it. Okay, and then you can set it up here this way. You're not going to want it to be 1, 2, 3, right? You're going to have it more set up. So this is like 10%. And if it's a little too hard to see, again, you can bring it over here. This is 10%, right? So it's trait frequency and percentages. This would be 20%. And then you'd work your way up to 100%. And then again, you can move it to where you want it. Okay, and clean it up however you want to. But now you've got it set up that way. You can also, again, zoom out if that helps you. As far as then, how are we going to plot our data? Okay, you go into insert, you can go into a shape, okay, and then once you just create a shape, say that's the size that you want it, you can just kind of keep copying and pasting that shape wherever you want to. Okay, so I would like it a little rounder. Here it is. I'm going to put this in my key. So anytime I see a blue dot, I know that I'm dealing with an environmental factor of, of the wolves. Okay, so then I can copy and paste it again. Generation 1, we didn't have any wolves. Generation 2, we did, and our population percentage, whatever it was we calculated, let's say was like 13%. Okay, and this is the calculated version that you'll have in your table. Okay, and then by generation 3, let's say we were at 25%. Right now, I'm literally just making this up, but all of your data will come from your tables. So this is, all the way down. But now we want to plot this a different environmental factor. So can't have it the same color because then I don't know which one is wolves and which one's going to be tough food. So again, you would left click, right click, double click, whatever it is that helps you format your shape. Go to format, fill, and change your color. Let's say we want to do purple. Okay, so now I know every time I see a purple dot, I'm going to be looking at, this is when we were looking at tough food. So let's say tough food, we were up here. And then maybe, oops, we don't want to resize it. We just want to move it. And I actually don't know how the data is going to look. I'm just trying to show you how to set up your tables and graphs. Oops. Okay, so now I've got two things that are labeled. We need one for limited food. So let's grab one of these again. I'm going to copy and paste it. I'm going to put it over in my key. Let's change this color to yellow. So we're nice and different. Not sure I like the purple because the purple is pretty similar to the blue. Maybe we want to make it a little different and we can do that too. So let's say here, and then let's say this one goes here. Oops. Right, grab it, copy and paste it. And again, all of this is just going to be coming straight from your tables. Okay. And then whatever colors that you do choose for this key, you'll use consistently throughout the document. So I've got, let's say, all my generations done. I've got all of this plotted. Um, Another thing you'll have to do is your line of best fit, right? So for that, easy breezy, you're going to go up to insert again, shape, and we want a straight line. And that's really hard to do unless you use the insert shape tools. Okay, so as I'm taking a look, here's my data. We want to start in the origin, or right there at the beginning here. And we're going to just try to draw a line that kind of really shows the way that most of this data would fit. So I think that's not quite going to work, right? If I were to graph it, I would probably do a best line to fit something like that. Okay, again, if you want to change its colors or change how thick it is, maybe I want my line to be green. I can go back to here and I can maybe make it a little bit bigger, however you want to. But here's my line of best fit. Hey, this is, so you'll practice doing that. So we need to know what is our correlation coefficient value. Let's take a look at this. You're going to go back up to the example of our correlations here. Okay, and see which one of this most likely looks, does it look more as a perfect correlation? Is it strong? Is everything really, really close to the line? Are we looking at about maybe 50%? Is there no correlation? So you'll use this chart to help you determine your correlation value. You can put that in with the questions. Okay, strength, again, will go based off your correlation value. Does this suggest causation? And if so, why? That will go back up to reading through our checklist here, summary how to decide correlation versus causation. Okay, if yes, you can test causation. If yes, suggest causation. Okay, so just kind of working your way through that. The second part of your graph, after you've done all of the environmental factors, is you get to do one with all of them turned on all at the same time. Okay, so this is part 2. So we're going to go back to looking at the lab again. So we're back here. Okay, we've reset it because again, we're wanting to take a look at now all of the mutations as well as all of the environmental factors. So you turn the fur on, turn the ears on, turn the teeth on. Okay, you're going to go ahead and add your mate. You're going to let it go through 3 generations before you introduce your environmental factors. Okay, so there's generation 1. If I don't want to sit around and wait, that's fine. But don't forget that you still want to pause at the end of each generation to do your data. So if you need your data probe again, you can line it up with, okay, this is generation 1. This is our numbers. And again, it shows you which ones are which. Again, you're going to want to take a look at pedigree. So here's your pedigree. This is generation 0. This would be generation 1. Okay, go in here. We're going to add it. Again, if I want to fast it. Hey, there's generation 3. Okay, at the end of generation 3 is when we're going to add all our environmental factors. 1, 2, 3. Okay, and now we can kind of see, here's when we did our environmental factors. and then what happened as a result of that, we can check with our numbers. And you'll let that go for 10 generations total, so another 7 generations, and we'll see what's left. Okay, pausing there. We'll go ahead and reset. Look back at our document. And you can see here, we don't have any environmental factors here. It's all of them. Your total population, your dominant traits, and then down at the bottom, you'll have to do your trait frequencies. So if you want to, you can add another column here. I insert column to the left, and then this would be your trait percentage. Okay, so you can work on that too. And then once you finish with that, same thing with your different key here. Okay, keep with the same one above. You're only going to be doing your dominant traits, so you don't have to worry about that. Do your correlation coefficient, and then here are some questions that I want you to think about. Okay, answer the questions below, and that is your lab. All right, folks, I will see you the next day we have class. I hope you have a wonderful day.